One of the most fundamental questions a scientist can ask themselves is, well, what is light? And depending upon who you ask and how it's measured, light can either be described as a wave or as a particle. For our purposes, we're going to talk about light as a wave, so it would be good to describe some properties of waves, right? And these properties hold for any type of wave, whether it's a light, a sound, a water wave, or a wave in the earth due to an earthquake. Okay? So very generally, let's draw a stereotypical wave. So I'm going to have some kind of a crude, what's not very symmetric wave. Okay? This has a couple physical properties that you should be able to see immediately. Okay? First of all, it has some height. And by height, I mean height from that horizontal equilibrium line, right? And so this maximum height, or maximum depth, if you will, that's known as the amplitude. Okay, that's the amplitude, and that's the same value or same height on the top as the bottom, and that holds for all points on the wave. Okay, so you can say that that amplitude value is characteristic of this wave. Okay, I should mention that this horizontal line, that's, well, zero amplitude, right? If there was not a wave at all, or if there was not, say, a light source emitting light, well, you'd basically have a straight line. There wouldn't be a wave. So we're comparing all waves from this kind of 0 point, okay? So this hypothetical wave I've drawn here has some amplitude. It's, yay high. Amplitude is also sometimes referred to as intensity, right? So we can also write intensity as kind of a scale, right? On the vertical axis, intensity or amplitude, okay? And so that's kind of a vertical height, right? Okay, the next characteristic of a wave is, well, the wavelength. It's the distance from, say, this point to this point. That's the distance of this wave. And that distance is such that if you start at one point on the wave, you go through one peak and one valley, and you return to the exact same, to the very next identical point. Okay? So in this case, that's that distance. Right? Light waves have wavelengths on the order of several billionths of a meter. Light waves are incredibly small, okay, but they're very energetic, and we'll see why in a second. Okay, so a wavelength is, say, the distance from, well, that point on this wave, since the wave is tending to go up, passes through a peak, back down, passes through a valley, and back up to that same point on the wave. So this horizontal, that horizontal distance is the wavelength. That's the same distance as from peak to peak, or valley to valley. Okay, so I should also put that up there. That's also one wavelength. And again, like amplitude, this wavelength distance will not change at any point on this wave, right? Assuming the source of this wave doesn't change. So if you can imagine this wave simply vibrating up and down, right, as it moves left or right, the distance of the wavelengths won't change. It'll always look the same, okay? And so the third characteristic is the frequency. I can't really draw that on the diagram, so I'll define it below. The frequency, I'll leave a little space, is the number of complete cycles per time, right? Usually time is denoted in seconds, so the number of complete cycles per second, but I'll define it in the general terms. So what do I mean by a cycle? Well, cycle is basically one complete wave. Let me put that on there. One complete wave, right? So that's one cycle. It's going through one peak and one trough and returning back to the same position on the wave. Another cycle starts at one peak, down through one trough and up to another peak, right? That's a cycle. And another example is trough to trough, right? I just realized that I said trough instead of valley. Those two terms are interchangeable, okay? Trough or valley is this low point down here, low point down there, okay? We give these properties some variables, right? You might see the amplitude as A. The wavelength you'll see as the Greek letter lambda. So let me put that over here. This is spelled L-A-M-D or L-A-M-B-D-A, lambda. And then frequency is simply F. Okay. So amplitude, wavelength, frequency. Again, for a certain or a given wave source, these three characteristics will not change as the wave simply exists and is vibrating in space. Okay? And that's it, right? In the next video, we'll talk about how these properties can change for different colors of light.